In this example, we have x equals 2t squared plus 1 and y equals 1/3 t cubed minus t. And remember what our formula says. It says dy dx is just equal to dy dt over dx dt. So don't try to memorize step 1, step 2, step 3. Just memorize that one formula and it tells you what to find. What does that one formula tell us we have to find? The derivatives with respect to t of both y and x and create that ratio. And that's it. So I'll do that work over here. What is dy dx here? I'm sorry, dy dt rather. So the top part. So look at the parametric equation, y equals whatever, and take the derivative. What does that turn out to be? T squared minus 1. Okay. And then we've got to do the bottom one. dx dt, oh, x is 2t squared plus 1. What's the derivative? 4t. So what is dy dx then in terms of t? It's important to remember it's in terms of t. What is dy dx? Well, that's why I found dy dt first. You remember to take in ratio this guy on top, this guy on the bottom, and that's it. So t squared minus 1 over 4t. Does that make sense? You're thinking, you're getting suspicious, right? It's got to be harder than that. Well, I mean, yeah, the functions could be harder to deal with, right? And there are some things we'll talk about tomorrow that do get a little bit more interesting. But let's continue on with this example, get through this one. Now, back to a calculus 1 type problem, except we're in parametric form now. Find the equation of the tangent line at t equals 3. Well, okay. So we have to review a little bit. What does the derivative dy dx give us? Slope of what? The curve or the line tangent to the curve at any particular point, right? Yeah. So we just found the slope of the curve at a generic value of t, which generates a generic point when you plug it into the parametric equations. So we've got to take what we got in part A and figure out the slope we get when t equals 3. So we need to take the dy dx that we got in the last part and evaluate it at t equals 3. So one notation for that is this. dy dx, which we know from part A, and then that line and at the bottom t equals 3. That means dy dx evaluated when t equals 3. That's going to give us our slope. So before that, let me put m. This is our slope subscript tangent line. That's our slope of our tangent line, right? At the point generated by t equals 3. So, okay, well, that's easy enough. Let's plug in 3 into t squared minus 1 over 4t. So that would be 3 squared minus 1 over 4 times 3, right? T squared minus 1 over 4 times t, where t is 3. So what does that give us?
8 over 12.
So 8/12 or 2/3. Yeah. So this is the slope of the tangent line. Let's be clear. Slope m of tangent line. Okay. In order to find the equation of a line, the tangent line is a line. In order to find the equation of a line, you need two things. What do you need? What two things do you need? One of them is slope, right? And the other is, I think you said it, Sarah, a point. So how do we find the point on the curve that this line is tangent to when t equals 3? Let's call this the point of tangency. Tangency. That's how I'm going to spell it, even if that's not how you spell it. Point of tangency. What? Okay. What gives us points on the curve? The original parametric equations represents all the points on the curve. We just need the one where t equals 3. So go back to the original parametric equations. X equals whatever it was. I don't even remember. Whatever it was. 2t squared plus 1. Y equals 1/3 t cubed minus t. And we're going to plug in 3 into both equations to get the point where the tangent line just kisses the curve, right? So y equals 1/3. So the y coordinate will be 1/3 3 cubed minus 3. Okay, so what are these x and y values? Let's see, we have 9 times 2, 18 plus 1, 19. You guys do the next one for me. See, 27 divided by 3, 6. Yeah? Okay, so the point of tangency, 19 comma 6. So we've got a slope of 2/3. We've got a point 19.6. Now it is an algebra problem, right? To find the equation of that tangent line. So I recommend this equation. Remember this? Remember this equation, y minus y1 equals m times x minus x1? Yeah? All right, plug and chug. What do you get? Y minus 6 equals 2/3 times x minus 19. There we go. Okay, in part C, we're going to take the second derivative of y with respect to x. Okay, so that we don't have to repeat our work, here's all the information we found from the first example. Okay? Oh, so what we're going to do here is figure out a way, in terms of t, that is, to find the second derivative of y with respect to x. Does everybody understand what we're doing then? Our answer should be written in terms of t. Okay, well, I want you to recall then that the generic formula for dy dx in terms of t is dy dt divided by dx dt. But now, taking over the role of y in this formula, so let me circle the y. Taking over the role of y is the first derivative, dy dx. If you want to, so in other words, you want to take the derivative twice, right? So we want to apply that same formula for dy dx again, except now our y is equal to the first derivative, dy dx. So now when we apply this formula again, instead of having a y here, we're going to have the first derivative here. So generically then, the second derivative, so this is I'll put it in red here. This is a formula worth knowing. Generically here, the second derivative of y with respect to x is going to equal, okay, look at this formula. It's going to be d dt of not y. That's what's on top in the first formula, right? dy dx is the same as d dt, or dy dt rather, is the same as d dt of y. So we're not going to have this y here. Instead of having that y here, just substituting the first derivative in, you get d dt of dy dx. That's on top. But then the denominator stays the same, just dx dt. In other words, long story short, what's acting like y is dy dx. dy dx acts like y. So this guy is your formula that you can use to find the second derivative. Now, in order to use this formula, you have to have what? You have to have the first derivative. So you use the first derivative to find dy dx, which we already did at the end of last class. And now we're going to use this formula to find the second derivative. Okay. So that means we need, since dy dx, with respect to these equations, these parametric equations, x equals 2t squared plus 1 and y equals 1/3 t cubed minus t, dy dx is t squared minus 1 divided by 4t. Let's go ahead then and find this numerator here. We'll do that separately because it gets messy if you don't. So let's find d dt essentially of t squared minus 4t, minus 1 over 4t rather. So let's find d dt of that derivative t squared minus 1 over 4t. And then we'll put that over dx dt, which will be, we already know from the last example. Okay, so what rule do I need to apply here to find the derivative of t squared minus 1 divided by 4t? It's a quotient, right? Let's use the quotient rule. Low d high minus high d low over low squared. So what, the low function being 4t, the high function t squared minus 1. So what is low d high? 4t times 2t. Minus high d low, what's that? Quantity
T squared minus 1 times 4.
over low squared, what's that?
4t squared.
Yeah.
Quantity 4t.
Right, good. Yeah. So you got to square that 4 as well. Right? Everybody agree with that? Okay. So, well, what do we get here when the smoke settles? I guess I have 8t squared here when I multiply 4t times 2t, and then distribute out the, okay, it's really a minus 4 that you're distributing, right? So distribute out a minus 4, and what do you get? So you get a minus 4t squared. Help me out here. What would be the net? What would you be adding on the end then? Plus 4. Okay, just seeing if you're awake. All over 16t squared. All right. So what does the numerator become? 4t squared plus 4? Or if I factor out of 4, what's left in the numerator? T squared plus 1 over 16t squared, which is equal to just t squared plus 1 over 4t squared. Okay? So now we're ready to find the second derivative by putting that over dx dt. So the second derivative of y with respect to x then is going to be what we just found, t squared plus 1 over 4t squared. And then dx dt, I mean, we could recalculate it if you want. We did it yesterday, but it's easy enough to just recalculate. What is dx dt? 4t. So that thing divided by 4t, but you can think of it as 4t over 1 if it helps. Flip and multiply. What do you end up with? T squared plus 1 on top. 16t cubed on the bottom.